In section 2.2, we're going to look at graphs of different types of functions. And first of all, if we need to determine if a graph is a function, we can use the vertical line test. And I know that many of you have seen and done this before, but basically, if you draw a vertical line through any graph and it intersects in more than one point, then it is not a function. Okay? So if we look at these examples over here, example 1, anywhere I draw the vertical line, it only hits in one spot. So we would say that this is a function. In part B, I draw the line through any spot on that graph, and it hits in only one spot. It is a function. In part C, we draw that vertical line through any place on this graph, and in this case, it's going to hit in more than one spot, so this is not a function. And the same thing with this circle over here. Any vertical line that's drawn and it touches in more than one spot is not a function. And that's because if you remember the definition of a function, for every x value, there is exactly one y value. So looking at this x value that's right here, I have a y value that's up and a y value that's down. It's more than one y value, and it's not a function. So in the next part, we can look at a graph and get lots of information from that graph. So here it says if xy is a point on the graph of a function, then y is the value of f at x. Okay, and in that case, y equals f of x. And we have to remember that y and f of x are equal. Okay, y and f of x, they are the same thing. So over here it says, given the graph, find the following information. What is f of 0? That means what is the value of the function when x is 0? So if I go over here and I look at x is 0, which is right here, and I go up to where it hits the function, the value of that function is 4. Remember, the value of the function is still the same thing as y. So if x is 0, and I would say f of 0 is 4. The next one, I want to find the value of this function when x is 3 pi over 2. So if on the x-axis I find 3 pi over 2, which is here, and y, the y value is 0, I would say f of 3 pi over 2 equals 0. And then I have the value of the function when f is 3 pi, when x is 3 pi. So I'm finding f of 3 pi. So on my x-axis, I'm going to find 3 pi. That's my x-coordinate. And the y value there is -4. So that's the value of the function when x is 3 pi. It's equal to -4. Then it's asking us about the domain of the function. Okay, so remember that the domain are the x values that we see on this function. And if we notice, our x values stop here. They stop or start at 0. We don't have any negative values here. Okay, and if I continue on, my x values stop at 7 pi over 2. All right, so my x values don't continue on. There's no arrows. So our set of x values is closed. That means we have a limited amount of x values. In this case, our domain is going to be the set of numbers between 0 and 7 pi over 2. Now, normally we would write 0 is less than or equal to x, which is less than or equal to 7 pi over 2. Oh, and actually it goes to 4 pi. Sorry, I didn't see that this was even higher. All right, so this is 4 pi on the x-axis, and this is 0. So I'm going from 0 to 4 pi. This is how we write this in algebra and before calculus, but as we approach writing notations in the form that would be acceptable in calculus, our domain is going to be using brackets or parentheses, and I'll show you the difference of each one. So the domain starts at x is 0. Because it includes 0, I have a bracket. If it did not include 0 and I had an open dot on 0, then I would have a parentheses to indicate that it's not closed. And the y value, and I'm going to kind of write this as an ordered pair, or my highest value, not y value, my highest value is 4 pi. So this means I'm going from 0 to 4 pi, and the brackets means that these numbers are included in my domain. All right, so the range is very similar, but I'm looking at my y-axis now. And my y-axis starts at -4. That's the lowest y value I have. And it goes up to +4, where my x-axis started at 0 and went to 4 pi. So for my range, and I usually start at my lowest number, which is -4, and there is a closed dot here. So -4 is included in my range, and it goes up to a high value of +4. And it's got a closed dot here, so it is included in our set. Okay, the next one says to list the intercepts. All right, so the intercepts we know are the points that intersect our axes. So the x-intercepts are the points that are on the x-axis. So I have pi over 2, 0. That's the point that's on the axes. I have this point right here, which is 3 pi over 2, 0. My next point is 5 pi over 2, 0. And my next point and last point is 7 pi over 2. And the y-coordinate is 0. These are the points that intersect the x-axes. The y-intercept are the points that intersect the y-axes. And in this case, the only point that's on the y-axis is 0, 4. And here's a hint. If you have more than one y-intercept, you can't have a function because that x value would be 0 and it would be there twice. All right, so most generally, if you're working with functions, you're only going to have one y-intercept, but you can have as many x-intercepts as the function shows us. So part E asks us for what values of x does f of x equal -4? Now remember, f of x is just y. So I want to know where on my graph does y equal -4? So if I were to go on my y-axis and I look for a y value that is -4 that's on my graph, I would say that x would equal pi, because pi -4 is on our function, and x would also equal 3 pi, because the y value here is -4, the x value is 3 pi. Now it says, for what values of x is f of x greater than 0? And here, if I look at my function, remember f of x is y, and I want to know where is y greater than 0. So that would be all of the spaces or all parts of the function that are above the x-axis, because here are the y values that are greater than 0. So we don't have just one specific point, because even though here's a y value of 4 and we know that's greater than 0, this point right here is also a y value that's greater than 0. So now we're going to use our set notation to describe where y is greater than 0. So y would be greater than 0 in this set of x values. So the x values, that's what we're looking for, are between 0 and pi over 2. So I would write that as 0. This time I included a parenthesis instead of a bracket because I don't have an equal sign here. Okay, at y equals 0, that's not what we're looking for. We're looking for the numbers that are greater than 0. So I'm starting at 0 and I'm going to the x value that is right here, which is pi over 2. Okay, and again, pi over 2 has a y value of 0, and we're not including that. So this is our range, or this is the domain that gives us a y value greater than 0. Okay, in the past, I could have put this as x is greater than 0 and less than pi over 2. That means the same thing. Okay, we're just kind of shortening it up a little bit. We can also look at other parts of the graph that are also greater than 0, like this part right here. And again, in set notation, we're starting at 3 pi over 2, and we're going all the way up to 5 pi over 2. At these points, the y value is 0, so we're not including those, and we're just using parentheses instead of brackets. So this is showing us that our x values between 3 pi over 2 and 5 pi over 2 give us a y value greater than 0. And there is one more part of our function that is greater than 0, and that includes the interval of 7 pi over 2 to 4 pi. Now, 7 pi over 2 gives me a value of 0, but 4 pi gives me a value of 4, which is included in my y value is greater than 0. So here, I'm going to use a bracket to indicate that 4 pi would be included in this set that gives me a y value greater than 0. All right, so moving ahead. Sorry. Now we have a function. We don't have a graph here. I guess I could graph this, but we're just going to look at the function notation of this graph. And we want to answer some questions about this in relation to functions. So part A says, is the point 1, 1/2 on the graph of the function f? So now remember, 1 is our x value, 1/2 is our y value, which is also f of x. So in this case, if I plug in 1 into this function and do the calculations, I want to know if I get 1/2 as my answer. So in part A, I'm going to plug in 1. So I'm going to do f of 1, value of the function at x equals 1, and that equals 1 plus 1 over 1 plus 2, which is 2 over 3. Okay, because 2 over 3 is our y value, and it doesn't equal 1/2, the point 1, 1/2 is not on the function. Or no. Part B says, if x equals 2, what is the value of the function at x equals 2? So in part B, x equals 2, so I'm finding f of 2. If I plug in 2, 2 plus 1 is 3. If I plug in here, 2 plus 2 is 4. And this is our y value. So at x equals 2, the y value is 3/4, and the point on the graph would be 2 3/4. Okay. And don't get this confused with the interval notation that we used in the back. Sometimes that interval notation does look like a point, but it's actually representing x values. This is representing an x and a y value that would be on the function. Part C, if f of x equals 2, what is x? Okay, so I need to find out what value of x would give me a y value of 2. So that means, remember, f of x is y. Y is 2. So I'm going to plug in 2 for y, or f of x, and I'm going to solve for x. So I have x plus 1 over x plus 2, and this value has to equal 2. So I'm going to solve for x. So I'm going to I'm going to multiply both sides by x plus 2. So I have 2 times x plus 2 equals x plus 1. Sorry about that. This would give me 2x plus 4 equals x plus 1. Subtract x. So I have x, and if I subtract 4, 1 minus 4 is -3. So the x value of -3 gives us a y value of 2. The point on the graph f of x is the x value of -3 and the y value of 2. So part D says, what are the x-intercepts of the graph of this function? So what points are on the graph that are x-intercepts? So in this case, remember that x-intercepts mean y equals 0. So in our function, I'm going to set the value of the function, or f of x, equal to 0. So I have 0 equals x plus 1 over x plus 2. If I multiply both sides by x plus 2, 0 times x plus 2 is just 0, equals x plus 1. Subtract 1, and x equals negative 1. So our x-intercept is at negative 1, so the point negative 1, 0 is the x-intercept.